On December 11th, 1998, NASA launched Mars Climate Orbiter toward the Red Planet with two jobs: study Mars weather from orbit and serve as a communications relay for Mars Polar Lander, which would follow a few weeks later. It was an ambitious dual mission, and if it failed, you'd lose both the weather data and any way to talk to the lander once it reached the surface. So the stakes were real, and the spacecraft was on its way. And somewhere in the ground software back on Earth, a file was already producing the wrong numbers. The small forces file, the one tracking momentum management thruster firings, was delivering impulse data in pound seconds. The interface specification said it should be Newton seconds, and then the navigation software took those pound-second values and treated them as if they were metric, underestimating the actual velocity change from every thruster event. So from the beginning, the navigation team's model of where the spacecraft was and where it was going was quietly drifting away from reality. Every time the spacecraft fired its thrusters to dump built-up momentum, the model got a little more wrong, and no one knew. Why didn't the navigation team catch it? Because they arrived just before launch. The operations navigation team, the people who would fly the spacecraft to Mars, had not been part of the ground software testing. They had not attended the key design reviews, and they did not receive the attitude control information from the spacecraft team that might have tipped them off. So the one group positioned to question whether the thruster data made sense was seated at the console without the context, the history, or the details they needed to recognize that something was off. A latent error in a file format had just become organizationally invisible. And for the first 4 months, the problem stayed hidden for a different reason. The navigation team wasn't even using those desaturation files yet. There were file format errors. There were issues with the attitude data. So the files sat unused and the error sat dormant. But by April 1999, the files were in use and the navigation team started to notice something. The maneuvers were being mismodeled. They said it explicitly. The model wasn't matching what the spacecraft was doing. And at the same time, they realized the desaturation events were happening a lot more often than anyone expected, 10 to 14 times more often. So now you had two things happening at once. The team knew their model was wrong, and the thing they were modeling wrong was happening over and over, amplifying the accumulated error with every firing. The problem was no longer hidden. It was recognized. It was discussed. And it still wasn't corrected. So why not? Two reasons. First, the geometry. Much of each thruster firing happened in a direction that was hard to observe from Earth. The Doppler data, your main tool for checking the spacecraft's velocity, couldn't see it clearly, so the systematic error could hide inside the trajectory estimate even while the navigators were looking at the data. The evidence that something was wrong existed, but it was obscured by the orbital mechanics. And second, when conflicts in the data did appear, the teams handled them over email. Not through the formal incident and anomaly process that was supposed to force problems to closure, but through email threads that could trail off without a decision. And here's the part that makes it worse. If someone had compared the ground software's velocity change estimates to the spacecraft's own onboard data the spacecraft was generating and could have sent down, that comparison might have exposed the unit's problem. The tools to catch the error existed, but the operational system never required anyone to use them. So by the summer of 1999, you had a spacecraft approaching Mars with a navigation model that the team knew was wrong, an error that had been amplified by more than 10 times the expected number of firings, and no formal process driving anyone to compare the model to ground truth and close the loop. There was still one chance. A fifth trajectory correction maneuver could have been performed to raise the spacecraft's approach altitude. It wasn't. Later, the investigation would list that decision among 8 contributing causes, not as a guaranteed save, but as an opportunity that was not taken. The final window passed. The spacecraft kept flying on the trajectory it was actually on, not the one the navigators thought it was on. On September 23, 1999, Mars Climate Orbiter reached Mars. The actual trajectory was lower than the navigation estimate. The spacecraft began its orbit insertion maneuver, and then the carrier signal stopped. That was the last anyone heard from it. 9 months of flight, a recognized modeling error, 10 times more thruster firings than expected, months of detectable drift, and multiple opportunities to test and correct, all of it ending in 2 minutes of silence. This was not a story about one programmer who forgot that metric units exist. It was not a story about a typo that was impossible to catch. It was a story about an operational system that had formal interface specifications, anomaly processes, and the ability to perform correction maneuvers, and never used them to close the loop on a problem it knew about. The navigation team recognized by April that their model was wrong. They discussed it. They watched it compound with every extra thruster event. And the system had no requirement to force a comparison, elevate the conflict, test the root cause, or make a decision before the final approach. When you rely on email threads instead of formal closure, when the team that needs to catch the error is seated without the knowledge to catch it, when observable evidence exists but no one is required to compare it, what you get is 9 months of detectable drift followed by an ending you can't take back. The spacecraft that was supposed to study Mars weather and relay communications for the lander arrived too low, and contact was lost. And the most damning line in the investigation isn't that someone used the wrong units. It's that people knew something was wrong, and the system wasn't built to force them to find out what.